There is a number stamped on the side of certain truck engines that sounds like a typo. 1,000,000 miles, not the truck, the engine. The same block, the same crankshaft, the same pistons turning over after enough distance to drive to the moon and back twice with room to spare. Now park that next to the family sedan rusting in a driveway because the motor gave up somewhere around 200,000. Same century, same basic idea. Fuel goes in, pistons go up and down, wheels turn. So why does one of these machines outlive the other by a factor of 5? The lazy answer is that trucks are just built tougher. That is true, but it explains nothing. Tougher how? Tougher why? Because the moment you actually open up a heavy-duty diesel and look at the decisions the engineers made, you realize none of this was an accident. 1,000,000 miles was the assignment. Everything else got sacrificed to hit it. Let's get into it. Here is the simplest possible version. The one you could explain to someone who has never popped a hood. A car engine is built to be quick, light, cheap, and quiet. A truck engine is built to refuse to die. Those are not the same goal, and you cannot fully have both. Every choice the diesel engineers made bent towards survival, even when it cost them speed, weight, and money. Once you see the world through that lens, the 1,000,000 miles stops being mysterious and starts looking inevitable. So let's go one layer deeper because this is where it gets good. The first big fork in the road is how the fuel even ignites. Your gasoline car uses a spark plug. It mixes fuel and air, then fires a little electrical spark to light it off, thousands of times a minute. A diesel does something stranger. It takes air and squeezes it so hard that the air itself becomes blisteringly hot, and then it sprays fuel into that superheated air. The fuel ignites on its own from the pressure and heat, no spark required. That is why it's called compression ignition. This sounds like a small, nerdy detail. It is actually the root of everything. Because to make compression ignition work, a diesel needs a much higher compression ratio and a much beefier bottom end to handle those pressures. And an engine built to survive that kind of internal violence is, almost by accident, an engine built to survive everything else too. But the real gift of the diesel cycle is the one nobody points to. Speed, or rather the lack of it. Watch a tachometer in a semi-cruising down the interstate. It's sitting somewhere around 1,500 RPM, maybe less. A gasoline car at highway speed is often spinning closer to 3,000. Think about what that actually means over a lifetime. RPM is revolutions per minute, the number of times every piston slams up and back down. The truck is doing the same job, moving down the road, while its internal parts cycle roughly half as often. Wear is cumulative. Every up and down stroke rubs metal against metal a tiny amount, even with perfect oil. So if you cut the number of strokes per mile in half, you have quietly doubled the distance the engine can travel before those parts wear out. That low, lazy, torquey RPM band is not just for fuel economy, it is the engine pacing itself for a marathon, while your car sprints itself to death. Now layer in the metal. This is where the contrast gets almost comical. Modern passenger car engines are obsessed with weight, lighter engine, better fuel economy, faster acceleration, easier handling. So they're built largely from aluminum with thin walls and clever castings shaved down to the gram. It's brilliant engineering for what a car needs to do. It is also a body designed for a 40-yard dash, not a 1,000-mile haul. A heavy-duty diesel block is the opposite philosophy poured into iron. Thick cast iron walls, massive main bearings holding the crankshaft. A crankshaft itself forged like a piece of medieval weaponry. Yes, it's brutally heavy. The engineers did not care. In a truck that already weighs 40 tons fully loaded, a few hundred extra pounds of engine is a rounding error. What that mass buys them is rigidity and the ability to soak up heat and pressure without flexing or cracking. And here's the part that ties it together. These big diesel components are deliberately run well below their actual limits. Engineers call it safety margin. The engine is capable of far more stress than it ever sees in normal driving, so it spends its entire working life loafing along inside its comfort zone. A part that is never pushed to its edge simply doesn't fail the way a part screaming at its redline does. If you're a gearhead, hit subscribe, because this next piece is the single most important design decision in the whole engine, and almost nobody outside the industry knows it exists. It's called the cylinder liner. And in the best diesels, it's a wet, replaceable sleeve. Here's why that's revolutionary. In your typical car engine, the cylinders, the holes where the pistons travel, are bored directly into the engine block itself. When those cylinder walls finally wear out, you have a serious problem. You either machine the whole block oversized, which is expensive and finite, or you scrap the engine. The bore and the block are one piece. They live and die together. A heavy-duty diesel says no thanks. Instead of boring the cylinders into the block, it drops in separate metal sleeves, the liners, that the pistons run inside. These liners are surrounded by coolant, which is why they're called wet liners, and when they wear out after hundreds of thousands of miles, a mechanic doesn't scrap the engine. He pulls the old liners straight out and presses fresh ones in. Sit with that for a second. The wear surface, the part that actually erodes over time, is designed from day one to be removed and replaced. The engine was built to be reborn. A heavy-duty diesel can get what's called an in-frame rebuild, where the liners, pistons, bearings, and seals all get refreshed without even pulling the engine out of the truck. After that, the odometer is irrelevant. Mechanically, it's a fresh start. That is how the same engine block crosses 1,000,000 miles. It doesn't survive untouched. It survives because it was designed to be healed. Now let's talk about the bloodstream. Because oil is doing way more heavy lifting here than people assume. Your car holds maybe 5 quarts of oil. A big diesel can hold 12, 15, sometimes more gallons. That is not a small upgrade. That is a different category of thing, and the volume matters for 2 reasons. First, heat. Oil isn't just lubrication, it's a coolant, carrying heat away from the hottest, most stressed parts of the engine. More oil means more capacity to absorb and spread that heat, so nothing ever cooks itself. Second, contamination. As any engine runs, it generates microscopic metal particles and combustion byproducts. Those particles are sandpaper. In a tiny oil system, they concentrate fast. In a huge oil system with heavy-duty filtration, they get diluted and trapped and swept away before they can grind your bearings into dust. The diesel is basically running a dialysis machine on its own bloodstream the entire time it's working. But all of this engineering would still be wasted if the engine lived a hard life. And here's the thing the spec sheets never tell you. The biggest factor in engine longevity isn't the engine at all. It's how it gets used. Think about the worst possible life for an engine. Cold start. Drive 2 miles to the store while everything is still freezing and the oil is thick. Shut it off before it ever fully warms up. Repeat twice a day for years. That is the daily reality for most passenger cars, and it is mechanical torture. Cold starts cause the most wear of any moment in an engine's life, because the oil hasn't reached where it needs to be yet. Short trips never let the engine reach its happy operating temperature. Now picture the life of a long-haul truck engine. It starts up once, warms up fully, and then runs for 10 or 12 hours straight at a steady temperature. A steady load, a steady RPM. No constant cold starts. No stop and go. No thermal shock. Just hour after hour of the gentle, consistent, warm running that engines actually love. The highway is the easiest possible life for a motor, and the long-haul diesel spends almost its entire existence there. The engineering gives it the potential for 1,000,000 miles. The duty cycle is what lets it cash that potential in. So, let's put the whole machine back together. Compression ignition that demands a tough build. Low RPM that halves the wear per mile. Heavy iron components loafing inside enormous safety margins. Replaceable liners that let the engine be rebuilt instead of buried. A massive oil system scrubbing itself clean. And a steady highway life that never beats it up. None of those alone gets you to 1,000,000 miles. Stacked together, they make it almost hard to avoid, which brings us to the question I actually wanted to answer this whole time. If we know exactly how to build an engine that lasts 1,000,000 miles, why isn't your car one of them? And here's the part that flips everything. It's not that we can't build a 1,000,000-mile car engine. We absolutely can. We choose not to. Everything that makes the diesel immortal is the enemy of what a car buyer actually wants. That heavy iron block would wreck your fuel economy and your handling. Those replaceable liners and rebuildable internals would balloon the price of the engine. That low revving torque curve would make the car feel slow and sluggish off the line. That 15-gallon oil system needs space. A compact car simply doesn't have. To build you a car that lasts 1,000,000 miles, an automaker would have to hand you something heavier, slower, thirstier, more expensive and bigger, and then watch you walk across the lot and buy the lighter, faster, cheaper one instead. So the 1,000,000-mile car was never killed by engineering. It was killed by economics and by us. A trucking company keeps an engine because that engine is a tool that earns money every single mile, so paying for durability is a no-brainer investment. A car is a thing most people replace long before the engine would ever wear out anyway, so durability past a certain point is money nobody wants to spend. The semi-engine isn't a miracle, it's a mirror. It shows you exactly what's possible when survival is the entire point, and exactly what we quietly gave up the moment we decided we'd rather have light, fast, and cheap. The technology to make almost anything last was never the hard part. Wanting it badly enough to pay for it always was. If that reframed how you look at the machines around you, the engineering channel you're on covers the hidden why behind the trucking and construction world every week. The next one breaks down a design decision sitting on the front of every American truck that most people have never once thought to question. Go watch it.